Returning for our last question to a concept that will definitely be in A-level curricula, that is the mass spectra of halogenalkanes. Mainly because chlorine, of course, has two isotopes, chlorine 35, chlorine 37, so they differ by 2 in a 3-to-1 ratio, so very easy to see where one chlorine is involved. Peaks differ by 2 in that 3-to-1 ratio. And then, of course, bromine is the other halogen that we like to study under this. Well, I've already talked about bromine earlier. Two isotopes, 79, 81 in a 1-to-1 ratio. Let's focus on chlorine here. So starting off, spectra L and M of 1,2-dichloropropane and 2,2-dichloropropane, starting off with L, and the peaks at 63, 65, 97, 99, 112, 114. So you can see straight off, I hope, 63, 65 separated by 2, so presumably there is chlorine 35 involved there, chlorine 37 involved there, 97, 99 again separated by 2, 112, 114 separated by 2. So what we're going to have to do here, because of this separation in 2, and look there, you can see a 1-to-3 ratio of the 65 and the 63, is we're going to have to think about the different fragments with the different isotopes in there. So starting off, there is 1,2-dichloropropane, and before I go further, it's going to be really tough with all the 35s and 37s and 35s and 37s. So I'm going to use a color scheme that anytime I'm talking about general chlorine, it's pink. Anytime I'm specifically on chlorine 35, it's green. And anytime I'm specifically on chlorine 37, it's in blue. So let's start off with just the fundamental molecule with both of the chlorines being chlorine 35. See, they're green. Well, add that up and the mass is 112. Oh, look at that. Okay, now then getting to 114, well, that's a gap of 2. So I am obviously replacing one of the chlorine 35s with a chlorine 37. And I can either replace the end chlorine or the branch chlorine there. Either one will get up to 114. So two possibilities here, which is why the height P ratio isn't 1-to-3, because this 114 represents two possibilities. The 112 just represents one possibility. If you squint, you can see the 116 peak down there, very, very teeny. That's where both of them will be chlorine 37s. So there we are. So the 112, 114 are the molecular ions associated with either both the chlorines being 35 or the two chlorines being one of each isotope. Now let's go to 97, 99. Well, going from 112 to 97 is a gap of 15. Going from 114 to 99 is a gap of 15. So we're going to presumably have lost a methyl group. So break that off and look first of all at the situation where we've lost the methyl group. Both of the chlorines are chlorine 35, and that's a mass of 97. And again, having one or other of them, I won't necessarily draw both of them, where either that one or that one is chlorine 37. Okay, so, and again, you see it's not a 1-to-3 ratio because there are two possibilities for this one. The blue chlorine could either have replaced this chlorine or replaced this chlorine. Now, last one, 63 and 65. Well, obviously the 63 is going to be involved with a chlorine 35. So 63 minus 35 is 28, and 28 is C2H4. So how can we take this molecule here and lose a chlorine and leave behind a C2H4 and another chlorine? And the answer is, put it right there. There's our C2, H3, H4 right there. There's the chlorine, and we've lost this fragment there. Okay. So starting off where we got one chlorine there, and there's only one chlorine, right? So that will be important when we come to the ratios in a minute. That's a mass of 63 when it's chlorine 35, and a mass of 65 when it's chlorine 37. And here again, there's only one possibility for the chlorine. It's there, right? So it's either 35 or 37. So here we see a 1-to-3 ratio for the chlorine 37 associated peak and the chlorine 35 associated peak. Okay. you could ask yourselves, are we going to see something associated with this bit there? Not going to be nearly as nice a fragment because this would be a primary carbocation as opposed to a pseudo-secondary carbocation. Well, that would have a mass of 35 plus 14 or 49. So there's the peak at 49. There's the peak at 51 that would correspond to having either a chlorine 35 or a chlorine 37 there. But I didn't ask you about those, so never mind. So now switching to spectrum M, in which we're interested in the 77-79. So that's obviously a chlorine 35 or chlorine 37 related. And look, there's that nice 1:3 ratio that we see there. And then we have 97, 99, and 101, which are again all separated by 2. Of course, we already saw the 97, 99, and a mention of the 101 previously. But anyway, there is our molecule. It has the same molar mass because, of course, it is just an isomer. And so that is, if both of these are chlorine 35s, then the molar mass is 112. So getting 97 is just again where we lose one of those methyl groups, the CH3, leaving with this very nice tertiary carbocation there. And that can have both of the chlorines, the chlorine 35, one chlorine 35, one chlorine 37, or one chlorine, or both chlorines 37, giving us the masses 97, 99, 101. Why do we see the 101 here? Because these are a little bit stronger than they were in the previous spectrum, because, and while it's dangerous to compare heights from one spectrum to another one, you've got this tertiary carbocation that you get when you lose the methyl group, which is a particularly nice one there. Now, how about 77 and 79? Well, how do those relate to the molar mass? Well, it's 112 if both of them are chlorine 35. 112 minus 77 is 35. So therefore, this is going to be where you lose one of the chlorines, giving us this nice stable cation here that's a again tertiary carbocation in quotes, but of course also one in which you don't have two chlorines, only one chlorine, so it's really a secondary carbocation with the chlorine there. So if this is A35, the mass is 77, nice and big. If the chlorine is 37, the mass is 79. And here again, we see that nice 1:3 ratio because there's only one chlorine position involved. Okay, if you go back to this one, 97 to 99 to 101, it's not that whole nice 3:1 ratio. It's actually a 1:9 ratio for the 235s and the 237s. And then, of course, in the middle here, you have the almost 2/3 possibility there. Explain the height ratio between 63, 65 and 77, 79. Well, I kind of anticipated here, didn't I? It's going back to what we assigned them, there's only one chlorine in the molecule. It's either chlorine 35 or chlorine 37. Thus, it reflects the usual 3:1 ratio that we expect for chlorines. And always, again, kind of discuss this a bit, dangerous to compare peak heights between different spectra, but the 97, 99, 101, much bigger here than here. Why was that? Well, this was where we lose the methyl group. So we either have, essentially call it a secondary carbocation with a chlorine there, or here a tertiary carbocation. And of course, tertiary carbocations much nicer than secondary carbocations.